So, folks, let me take you through graphs of functions. This is centered around IGCSE Extended Mathematics. And our main objectives, you are saying by the end of this discussion, one should be able to construct a table of values where you are having corresponding y-index values that you use to plot the curve. We should be able to do so for linear, quadratic, as well as simple reciprocal functions. We must also be able to solve graph by approximating. In other words, we sketch our curve, we check the points where our curve cuts the x axis. Those will be estimate of solutions. We should be able to make an interpretation of our intercepts. What do they mean to us? Shape and symmetry, as well as points of intersection. The key concepts that we might need to look at are, if you look at the variable x, if it's to degree 1, it means that graph is particularly linear, and the coefficient a of x denotes the gradient or slope of the curve, and b represents the y-intercept. Then for quadratic graphs, which we normally refer to as parabolas, they take the general form y equal to ax squared plus bx plus c, where a, b, and c are coefficients. And when we look at this curve, which is parabolic, it's symmetrical about points where our graph cuts the x-axis. So it has a turning point, and you can estimate the solutions to the graph graphically. Right. Reciprocal graphs, these are graphs that show an inverse relation. They are found in two parts, either the first and third quadrant or second and fourth quadrant, depending on the sign of the numerator or the coefficient a that we find above. And mind you, x, the denominator, cannot be 0, and therefore it tells us that this graph is going to have two asymptotes, the vertical and the horizontal. Right. When we look at graphical solutions, we solve by either the graph itself, looking at the points where the curve cuts the x-axis, or it intersects another curve. Then there's an example. If we're given a table of values we want to fill in, there's a relationship we are shown there, y equal to 2x plus 1. So these are the corresponding x values giving us the outputs y values there. So if we are to sketch a curve for this particular problem, we are saying something that we'll find generally is going to be a straight line graph where if we make our x 0, it means y will be 1 there. I don't know, we make our y 0, it means somewhere where it's negative. So it will be a straight line, it will be a straight line passing through those points of interest that I've highlighted there, like that. Then we can say y equal to 2x plus 1. They should correspond to the values that we have in our table. Then intercept identification, we are making either of these two zeros. If we make x 0 there, it means y is equal to minus 6, as we can see. If we make y 0, it means our x there is equal to 2. That's what we are seeing there. So those are called the intercepts. Then a quadratic table. So here we'll be interested in drawing a parabola like we discussed. So in whatever we do, this graph is going to denote sort of a U shape. So that's X, Y. And in red, I'm going to show you a basic graph. Let me redo it. Basic graph which shows a parabola in general form y equal to x squared. So these are transformations of the graph that I've showed. Minus 4 tells me I drop down that graph 4 units downwards. So where it says y is minus 4, I don't know, it will be something like that. And where we cross the intercepts, these intercepts, we are saying y will be 0. And if we check there, it means either there is minus 2 or plus 2. That's what we have there. Then moving forward, recognizing shape of the curve. When we are interested in the shape of the curve, we are looking at the picture that we get when we sketch our parabola. So we are saying a parabola is a graph which is more like an inverted U. So I'm given this particular curve or equation, but check here, the coefficient a is negative. So it's going to be a reflection of the graph that we have above there. So if I'm to sketch, I'm going to have a picture like this, x, y, whatever we do, we have reflected it, and we added 2. So where it says y equal to positive 2 like that, then we have our curve touching that point. So it will be generally a curve of that sort. That's y equal to minus x squared plus 2. It's just a vertical shift 2 units upwards. Reciprocal graph are the graphs, like we said earlier, they show inverse relation. In other words, x is on the denominator And when we are sketching this type of graph, it comes in two parts. We are saying for this curve, because this is positive, you will find it in the first and third quadrant, and the picture will be something of this nature. Right, so these lines where the graph do not touch, we call them asymptotes. So x cannot be 0, neither can y be 0. So those in red are our asymptotes. Right, so moving on, we might be interested in solving using a graph. If we are given that equation and we want to solve it graphically, we will rewrite it as y equal to x squared minus 3. As you can see, this is a parabola. So if I'm to sketch that parabola, it will give me a picture like this. I don't know, I've dropped the 3 units downwards, so somewhere where it's minus 3. So it's a curve more like this. And mind you, when I make it equal to 0, it is with the equation. As I proceed with the steps, it means x squared is equal to 3. So x will be equal to plus or minus root 3. So this will be minus root 3, and this will be positive root 3. That's what we have from the graph of y equal to x squared minus 3. Right, then on the seventh problem, where we want intersection graphs, these are graphs drawn on the same plane. And we spoke about is the basic graph y equal to x squared, but the other ones y equal to 4. So where we have got y being 4, we have another curve coming, that's y equal to 4. So in red, these are the points that we'll be interested in, and when we go down, we will have solutions to these two equations. That's the point where these two curves meet. Then next we have a vertical graph. A vertical graph is a graph where we do not have y. It's only x. And if I'm to sketch that vertical graph, it's any graph that do not have the y. So this one here in green is an example of a vertical graph. Let's say this was a point where x is 4. So this will be x equal to 4. It doesn't have y. Then horizontal graph, again, is a graph which doesn't touch the x-axis. So a sketch of this problem that we have there, I can just sketch a basic Cartesian plane to say x, y, and when we say y is minus 3, somewhere where you have your minus 3, you can draw your curve to say this curve is saying our y is negative 3. So as we can see clear, our curve doesn't cross the x. So that's an example. Then the last part 10, we might be interested in interpreting if a quadratic touches the x-axis once, it means it has one real root. Well, if it doesn't touch, it means it doesn't have real roots. And if it actually crosses, it means it has two non-roots. So we'll meet in the next section where we are actually solving problems together and see how those concepts can relate to what we are interested in when we talk of quadratic graph sketching as well as linear graphs. Thank you, folks. We'll meet in the next discussion. Bye.